So hi, yeah, I'm going to be presenting the biomass harmonization activity. This is just an overview really of what we're doing. So basically the activity came about following the refinement of the IPCC guidelines that include the use of above ground biomass estimates from spaceborne sensors. And when this happened, there was a realization that there are multiple global and regional above ground biomass products, and that these are all produced, as you may have noticed in the presentations today, with different data sources and with different methods, which means that they all have significant disagreements, which reduces their value for carbon accounting and reporting and estimating fluxes. And in addition, they all have different methods for estimating and reporting their error properties. So this leads to a lot of confusion for the user community. And we came together, therefore, in an international activity with multiple space agencies, so ESA, JAXA, and NASA, all contributing to this activity. With the product producers, we have also statisticians, and we have people working with country engagement, so that we can actually reach out to countries and liaise with them. So there's a really large team working on this, and we're making sure that it's an open science activity. So it's all undertaken on the ESA NASA multi-mission algorithm and analysis platform, which is a mouthful. So we call it the MAP, which leads to confusion. Okay, hang on. Yeah. So the first thing that we did was to set up a dashboard where people can access the products. So all of the products we have at the moment are available on this dashboard, and we are open to including other regional or global products. So if you have something that you want to share and you want to make available on this platform, then please do contact us or contact me. So you can zoom in, you can zoom out, and you can toggle between the different products. And when you do this, you'll see there is really quite a lot of difference. So you can see the link at the bottom, so anyone can go and have a look at these products. Also on the dashboard are country pilots. So for each country here, we have 5 examples. So countries are in different situations. They might have an NFI, they might not, they may have multiple dates. And so the idea is that we're working with all of these different countries and all of their different situations to look at how the products can be used to improve their reporting for the UNFCCC, but also how they can feed back to us on how the products are working or not working within their country or region. And there's currently, in tandem with this workshop this week, a workshop in Paraguay, which is being organized by Silver Carbon as part of this harmonization activity. And that's going to be presented by Daniela Requena and Joanna Mello tomorrow. So do come along and watch that one. So the next slides are just some initial results from work that's being done on the MAP platform. So this is work done by Veronika, Leitold, David Miner, and Laura Duncanson, where we're looking at comparing the MAP products. So here you've got the histograms of the densities, and it's done by biome and by continent. So here I'm just showing Africa with tropical and subtropical moist forests, with 4 of the products that cover that region. We have ISAT2 on there, but obviously as a boreal product, that's not included here. And so this has been done for all of the biomes in Africa, and it's been done on multiple continents. So bit by bit, we're building up pictures of how these products vary across biomes and continents. But we're also doing this on country scales, thanks to the engagement with countries and I say the sharing of data. The countries aren't necessarily always sharing their data. I'll talk in a moment about how we're achieving these things without actually having the plot data directly. So here I'm just showing the Solomon Islands and Japan, and this is just a CCI product and the NASA JPL. So just to give you an idea of some of the activities that we're undertaking, this is all ongoing work, so no final results just yet. So this is the plot to map framework. So what we've looked at in the previous 2 slides is how we can intercompare the products. And here we're looking at how we can validate the products. So comparing the products to in situ data. So obviously, if you're going to assess the accuracy of a map product, you need to account for the errors in the maps, but you also need to account for the errors in the reference data. So there's an initial quality control process that goes on that that takes away plots that have been deforested. It takes away old plots, so plots that are more than 10 years old, anything that has imprecise coordinates or if it's missing metadata. And then the remaining plot data is then harmonized because when you look at it, there are forest area and temporal mismatches between the plot data and the map products. And then there's going to be pixels in the map products that have forest area, non-forest area, and they are not going to match the plots which are only forest area. So there's a whole framework looking at how we can compare in situ data to plot data. So this system, this plot to map, has been installed into the map dashboard, or not dashboard, but the platform. And that works fully on the NASA side. It's been partially tested on the ESA side. So anybody can go who has plot data, and they can put their plot data in. So they can put their plot data into the map or use the tool within the map. So you don't have to share your plot location or anything like that. It can be done on a 1 degree pixel level rather than actually providing your reference data. So it allows countries or users with reference data that they aren't able to share to still provide information to the producers about how the product is performing within their country or region. So this has been done for multiple countries, and there'll be presentations on that tomorrow. But it's also been done with LiDAR data across Gabon. So this is the Elvis data, and this is a comparison of 4 of the products across Gabon on 1 kilometer aggregated level. So as you can see, there is a variation between the products, but in general, all the products are underestimating in the low biomass regions, overestimating in the low biomass regions and underestimating in the high biomass regions to varying degrees. So this is just a preliminary analysis, and Arnan Araza, who's been working on this from Wageningen, he's also looking at doing a bias adjustment, which does or should help improve these analyses. So that's about all I've got for the moment. I think I'm quite short on time. So it was just to give an overview of the activity, and a lot of these results you will see being presented in various other presentations in different conferences. I know at Forestat there's going to be quite a few things, hopefully.